This is a review on the topic of expanding and condensing logarithmic expressions. So the first one we're going to look at is the expanding part. So the directions will say something to the effect, use properties of logarithms to expand each logarithmic expression. So remember, in one of our lessons, we talked about these properties of logarithms. And so when we talked about expanding logarithms, we looked at the product rule, quotient rule, and power rule. And so the product rule says this: if you have the log of a product, some base, whatever the base may be, you can always expand it. Notice I'm using the word expand. You can always expand it to a sum of the two logs. So it'll be the log of m plus the log of n. So the two factors you see here. Okay, don't forget the base though. You must, whatever that base is, you must indicate it here. Then the quotient rule, so remember quotient, think division. So the quotient rule says this: if you have the log of a quotient, then you can always expand it using the difference idea. So using the subtraction. So it's the difference of the numerator, the log of the numerator, and the log of the denominator. All right, so notice the numerator goes first. The denominator, the factor that's in the denominator, is in the second term. And then the power rule says this: if you have the log of some number raised to a power, you can always rewrite it by putting that power as a coefficient in front. So it'll be p times the log of m. And so that's the expanding part. So let's look at number one. So number one, let's suppose we had this in number one. We have, and let's do 1a rather. So we're going to have the log of 100,000 times y to the second power. So the log of 100,000 times y to the second power. And remember, there's no base there. It's understood to be 10. So remember, this is a common logarithm here. So there's no base. It's understood to be 10. And so using our expansion rule, and so notice I have this product, 100,000 times y to the second. So I'm going to rewrite as an addition problem. And so this becomes the log of 100,000 plus the log of y to the second power. Now you want to simplify this as much as possible. So remember, this base is 10. And so if you notice 100,000, I can rewrite 100,000 as this, as 10 to the, and then that's going to be the fifth power. So you must always simplify if possible. So the log of 100,000, so that 100,000 can be written as 10 to the fifth power. And I'm going to go ahead and leave this like this for right now. And then notice I can use a power rule now, because notice I have a power. So I can rewrite this right here and pull that 5 out in front. So I get 5 times the log of 10 plus 2 times the log of y. Now again, simplify whenever you can. And so I want you to notice this right here, the log of 10. You know what the log of 10 is. Remember, the log of 10, the base here is 10. So remember, the log of 10 is going to be 1. And the reason is because if you looked at the log of 10, and if you put, let's say, box here, remember to change this to exponential, the base is 10, so it becomes 10 to the box equals the argument. So 10 to the first is equal to 10. So that's 1 right here. So this is 1. So it becomes 5 times 1 plus 2 log y, and you cannot simplify this. You can simplify this, and you need to. And so the answer is just 5 plus 2 times the log of y. Now, do not make the mistake and say that's 7. You cannot add those. Those are not like terms. See, that term contains the log of y. This does not. So those are two different terms. They're not like terms. All right, so there's your answer for part A. For part B, let's suppose we had this. We had the log base 4 of x to the 4th divided by y to the 8th. Now this time, I'm going to use the quotient rule. I'm going to expand using a quotient rule. So that's where we're going to use subtraction. So this becomes the log base 4, knows the base, write the base, of the numerator, so it'll be x to the 4th, minus the log base 4 of the denominator, y to the 8th. Now, at this point, Remember, you want to go as far as possible, so I can use the power rule now. So I'm going to pull this 4 out in front, pull this 8 out in front, and so I get 4 times the log base 4 of x minus, and pull the 8 out in front, so I get minus 8 times the log base 4 of y. And you cannot simplify this any further, so that's your answer. All right, so that was a review of using these properties as to expand logarithms. All right, so now let's look at number 2. Okay, so now on number 2, we're going to talk about condensing. So remember, this is a review. So we're only going to look at a few problems. So use the properties of logarithms to condense each logarithmic expression. So when you looked at the lesson on properties of logarithms dealing with condensing, so to condense, basically you're going to be given a sum, a difference, or a power, and you're going to write it as one logarithm. So to condense means to write it as one logarithm. So you can go from 2 or more to 1. And notice that the coefficient in front has to always be 1. So when you condense, this is what you're looking at. So you're going backwards. So remember, when you expand, you went from here to here. To condense, you're going from here to here. Okay? So let's go to number 1. So in 1a, we have this. We have 8 times the log base b of x plus 6 times the log base b of y. All right, so again, we're going backwards now. So before you can go from here to here, this coefficient here has to be a 1. That has to be a 1. Notice it is not a 1. This is an 8 and this is a 6. So the first thing you have to use is going to be this power rule. So you're going to go from here to here first. So in other words, I'm going to rewrite this as log base b of x to the 8th plus the log base b of y to the 6th. So I used the power rule. So I wrote this as this. Now notice the coefficients of the logs are now 1s. So now I can use the product rule. I can write this sum as one logarithm, the log of a product. So remember, the sum becomes a product. Difference becomes a quotient. So in other words, this becomes then the log, remember product, so log of base b of this product, x to the 8th, y to the 6th. And there's your answer. Okay, part B, we have 4 log base b of x minus 5 log base b of y. So again, this time we're looking at a subtraction. So subtraction of 2 logs with the same base. So that's going to involve the quotient rule. But remember, before I can use the quotient rule to write as one logarithm, this coefficient here has to be 1, and this has to be 1 here. So notice though, this is a 4 and this is a 5. You just think of this as subtraction. So you're subtracting a positive 5 log base b of y. So let's go ahead and bring this as an exponent and bring this as an exponent. So I get this. So using a power rule, I'm using a power rule now. So I'm going from here to here. So I get log base b of x to the 4th minus the log base b of y to the 5th. And now, since these coefficients here is 1 and 1, I can now write this subtraction as a quotient, as one logarithm. So I'm using this right here. So that's going to be the log base b of x to the 4th divided by y to the 5th. And so there's your answer. That's all you do there. So just make sure that coefficient here is a 1. And let's have one more. Let's look at C. So suppose in part C we had the log base 5 of x plus 2 minus the log base 5 of x plus 7. And let's go ahead and make this right here at 3. So let's say we had 3 log base 5 of x plus 2 minus log base 5 of x plus 7. So remember, before we can condense, before we can condense, and I'm dealing with subtraction here, so I'm going to use the quotient rule. Before I can write this as one logarithm, these coefficients have to be 1s. This is not, so I'm going to rewrite this using the power rule. And so that's going to become the log base 5 of x plus 2 to the third power, and that's already 1, so I'm just going to rewrite it, log base 5 of x plus 7. All right, and so notice, and always keep in mind that if you're going to use these property logarithms, those bases have to be the same, and so they are the same here. They're both base 5. So now I can write this as one logarithm using the quotient rule. And so this becomes the log base 5, and the numerator is going to be this, x plus 2 cubed, and the denominator is going to be x plus 7. And so notice you don't need, just to remind you, I can leave the answer like this, like the way I have it. I needed parentheses here. In the numerator, I do need parentheses because as x plus 2 is being cubed. Here, I don't need the x plus 7 in parentheses because that's just being raised to the first power. So you can leave the answer like this. Now, if you want to, you can. If you feel you want to be, you just want to do it, that's fine. You can say this. Okay? All right, but this is the one that you're probably going to see more often. All right, so that was a review. That was a review on expanding and condensing log expressions.